Hello, my name is Ava Caldwell, and this is my earthquake simulation project for EGN 3211 computational analysis. My 2D earthquake simulation is divided into three major components: initialization, fault lines, stress simulation, and user menu. So let's begin. So we import libraries such as Studio, Lib, Time, Windows, and Math. We define size 20, which creates a grid of 20 by 20. We declare a fault map array, which stores the locations of fault lines. The stress map array, which stores the locations or stores the values at each grid point. Stores stress values at each grid point, The handle and word variables are used to manage console colors, and the initialization functions include the initialization console colors, which stores the original console colors, set console color, and reset console color, manage color changes. And the initialize map function sets all values in both maps to 0. The libraries handle everything from input and output to visual styling. The grid-based model makes it easy to simulate the physical systems of the tectonic plates and sets up the console coloring, which plays a very important role in how we visualize increasing stress in earthquake conditions. The next thing we're going to talk about are the fault lines. So this section allows the user to draw different types of fault lines on the 2D grid. We have 4 functions that dictate the shapes of the fault lines, and then the void print fault map function to print it. It displays the current map configuration. In the draw horizontal row, it fills the map with ones indicating the horizontal line. The draw vertical fault function works similar. It updates a column instead. The draw point to fault function uses Bressenham's line algorithm to draw a diagonal line between any 2 points, calculates the difference between x and y. The draw circle function draws a circular fault by calculating x and y positions based on angle and trigonometric functions. It loops from 0 to 360 degrees. All right. Next, we're going to talk about stress simulation. The print stress. Okay, so the simulate earthquake function is the core simulation. It drives stress accumulation. The print stress function displays stress levels across the grid. This is where we see the console coloring. Helps us distinguish between the safe and dangerous values. If the value is green, it is less than 50. If value is yellow, it's between 50 and 100. And if it is over 100, it is red. A red on yellow text is high intensity and it's fault value, or has a stress value of 200, So the print stress map is called within the simulate earthquake function to do all of this. Together, the two functions simulate the display and build above the tectonic stress. The simulate earthquake function calls the print stress map every loop cycle to display the updated stress values. It also clears the system and slows it down for smooth animation. The print stress map displays the 20 by 20 console. The print stress map function is the function that provides visual feedback for each iteration of the simulation loop. So once a fault cell reaches critical stress, the simulate earthquake function ends the loop and announces the earthquake. And now we're going to talk about the user menu. So basically, this is displaying the random number generator. It clears the fault and stress maps and sets all values to 0. This is where the user is getting prompted to put the data for horizontal, vertical, point-to-point, and circle fault lines, and to start the earthquake simulation. And it calls the rest of the functions that I mentioned earlier to update the fault map. And it's going to show, this is what is going to show the fault map after every change. It calls the simulate earthquake function to begin the real-time stress simulation and visual display. And this is going to print statements about invalid inputs. And it goes in a loop until the program is stopped manually. After the simulation is run, the user will have an option to run it again. So here we are going to see how the program actually functions. So I'm inputting the data and I'm going through all of the different fault line shapes. And we can see that it's being updated on the display. The user is able to see it. Now I'm beginning the simulation. And as I mentioned before, we are seeing the random number generator. It's constantly refreshing. And we're seeing the stress build up upon those fault lines. And so we've got a point along the fault lines that's reached 200 and the simulation has ended. So throughout this code, I called libraries, the math and timing in Windows. I displayed arrays. I used the fault and stress map function to store values. I initialize console color settings, and I use set console color and reset console color to allow dynamic color change, so we can see we can visualize the levels of danger based on the color. I made the decision to do this instead of ASCII escape codes because when I would run the output, or the output would return with the color codes in them. So this just made it a lot cleaner. Thank you so much. I hope this was informative and I hope you enjoyed this.